Hello. Today we are going to walk through the steps for finding the spanning set for the null space and image space of a matrix. Before considering the following problem, it's important to highlight two definitions from our textbook. These can be found from an example 5.1.7 and example 5.1.8 of our textbook. First of all, the spanning set for the image of a matrix is nothing more than just the columns of the matrix itself. So when we're looking at the vectors that go into the span at the end, it is only going to consist of the columns of this vector, of this matrix, excuse me. Now, the spanning set for the null space is going to consist of all the basic solutions, the set x of n to ax equals 0, the homogeneous system of equations. And this is going to be found via the Gaussian algorithm. So when we first take a look at this matrix, I've simply reproduced it here already. The first thing we are going to look at is the spanning set for the image space. Now, as I previously just stated, the spanning set is going to consist of the columns of this matrix. So, looking at a label for each of these columns, C1, C2, C3, C4, and C5, we know, based on this definition, that the spanning set for the image space is going to be the span of C1, C2, C3, C4, and C5. Now, including the actual values, we know that that will be the set 3, 3, negative 2. So make this out for 5. And 3, 3, negative 1. 6, 6, minus 1. 6, 6, minus 6. Oh, I made a mistake. 6, 6. Minus 6, 6, 0, negative 6, negative 6, 2. So, as I previously stated, the columns 1 through 5 of this matrix will be the spanning set for the image space. Now, moving on from here, what we have the spanning set for the null space left to find. Now, to find the spanning set for the null space, from the definition, we know that we need to set up a system of equations that is equivalent to 0 and find the row-reduced echelon form of that matrix using the Gaussian algorithm. Because this is not the subject of the video, I've already ran through and done the row reduction process to produce this matrix. You can go ahead and verify this independently. You could also find this quickly by using Sage Math Cell if you wanted to. You would just simply write the matrix A dot RREF and close it parentheses. Now, before going further into this problem, just by looking at the row-reduced echelon form of this matrix, we can see that there are 2 leading ones. And 3 parameters. And when we write this out, we will get x1. First, let me just define our parameters and our variables. Now, since there's only two leading ones, we know that x3, x4, and x5 are all going to be represented through parameters. So we'll just go ahead and write out a representation for those. Now, going forward, when we write the rows out in terms of the homogeneous equation, we will get x1 plus 4r minus 2s equals 0, x2 minus 2r plus 4s minus 2t equals 0. From here, we just simply rearrange this equation, grouping parameters and variables on different sides. So from here, we will be able to get x1 equals minus 4r plus 2s, and x2 will equal 2r minus 4s plus 2t. Now, we have done everything we need to find the spanning set for the null space to finish up this problem. So what we need to do here to write out the vectors of the spanning set is to put these solutions in terms of their parameters. Simply put, group the variables. In doing so, you would get a vector 1, which is minus 4, 2, 1, 0, 0. Our second vector for the s having 2 minus 4, 0, 1, 0. And the way I'm able to do this, by the way, is by essentially grouping by parameter, in that if the presence of the parameter is included in the vector, it's represented with a 1, and the others that aren't included are 0. So in the first one, when r equals 1 and s and t equals 0, you're left with minus 4, 2, 1, 0, 0. And the second one, r and t equals 0 and s equals 1. So you have minus 2, minus 4, 0, 1, 0. And for the last one, when t equals 1 and r and s equals 0, our last vector is produced, which is 0, 2, 0, 0, 1. Now, these three vectors, in terms of the parameters that they represent, will be the spanning set for the null space. So our final answer here will in fact look as this. And now we have found the spanning sets for the image space and the null space of matrix A. Just to recap the process we used, we followed the two definitions established in examples 5.1.7 and 5.1.8 of the textbook. Simply looked at the columns of the matrix, put the second matrix in row reduced as echelon form, And lastly, took a look at the solutions of the homogeneous equation in terms of the parameters that were established in the equation. And here are our two answers. So thank you.